This is the homework helper for Chapter 14, Section 6 in the 8th grade workbook, Multiplying Binomials. So we're going to go ahead and start off with the first 4 questions that you see on your workbook page. Those are the 4 questions you see on the screen. As you see, my screen presentation looks a little bit different because I've cut off all the stuff that you're not or you will not see in the homework helper presentation. I'm going to do some problems down at the bottom of the page with you in a minute here, but right now we're only going to focus on 1, 2, 3, and 4. Remember, when we're multiplying binomials, we're using the process known as FOIL. FOIL stands for first, outers, inners, and last. And that's the process by which we multiply binomials. We have to take every part and multiply it by all the parts in the other binomial and then combine the results in order to successfully multiply binomials together. So let's go ahead and do that in number 1, and then we'll show you the table method that you saw in the note presentation today with questions 2, 3, and 4. So number 1, we've got z plus 1 being multiplied by z plus 2. So we want to identify the f, the o, the I, and the l here, because of course those are the 4 parts that we use when we multiply binomials. So f stands for the firsts. So we're looking for the first term in each binomial. Well, if we look at z plus 1 times z plus 2, the first term in each one is a z. So what we have here is z times z, and that's going to change into z squared. O stands for the outside, so we're talking the outside terms of what's written here. Well, on the outside here we have z and 2. So I'm combining z and 2, and when I multiply together z and 2, the result is 2 times z. I stands for the inners, or the insides, the inside terms of our binomials here. That's going to be 1 and z. So to find I, we're going to multiply together 1 and z, which is 1z. And L stands for the last. They're the last term in each binomial. That's 1 and 2. And I multiply those together, and I get 2. All right, so now it's a matter of me running all these answers together. And since they have plus signs and everything, we're just adding this whole thing together. So it's going to be z squared plus 2z plus 1z plus 2. Now, the thing is about that answer is these 2 middle terms are a set of like terms. 2z and 1z are like terms because they both have just regular z in them. So they can be combined. So I'm going to go ahead and combine those when I write my final answer here. So when I write my answer, I'm going to write z squared plus 3z, which is 2z and 1z put together, plus 2. So the binomial z plus 1 being multiplied by the binomial z plus 2 renders a product of z squared plus 3z plus 2. All right, let's go ahead and take a look at questions 2, 3, and 4 now. Now, as you recall from the note presentation today, in 2, 3, and the other questions that we did, we used FOIL here, but when we used FOIL, what we did here is we used a table method instead. And that's what I'm prepared to do here to work through questions 2, 3, and 4 with you. So let's go ahead and do that at this point in time. We've got 1 minus y being multiplied by 2 minus y in question number 2. So, using that table method, one of the things that was suggested that's going to make your life significantly easier is to change subtraction into adding the opposite. So that's one of the things we're going to do. As you can see, these are both subtraction problems, so they're both going to change into adding the opposite. So it's going to become 1 plus negative y into 2 plus negative y. All right, and now that we fixed that, now we're prepared to go ahead and make our table. Remember, the table looks a lot like a Punnett square you would do in science when you're looking at chromosomes. It's the 4-block square. And across the top, you're going to list one binomial. And down the left side, you're going to list the other binomial. So you've got 1 plus negative y across the top and 2 plus negative y down the side. Remember, we do not write the addition signs because that's the whole purpose. We change them to addition is because then I know that I'm just going to amalgamate everything here with addition signs and I don't really need to think about it. So each box then is the product of what's above it and what's to the left of it. So for instance, in this box, 1 is above it and 2 to the left of it. So this box is 1 times 2, or 2. This box here has 1 above it and negative y to the left of it. Well, negative y times 1 is going to give me negative 1y. This box here has negative y above it and 2 to the left of it. Negative y times 2 is going to give me negative 2y. And this final box here has negative y above it and negative y to the left of it. Negative y times negative y. Well, a negative times a negative is a positive. And remember, the product of powers rule says when we multiply together powers with the same base, we add their exponents. So since those would both be like y to the first, a 1 and a 1 adds together to make 2. So negative y times negative y is going to make positive y to the second. All right, so now I have y to the second. Now all I have to do is combine these answers here into one giant problem. Again, the whole benefit of changing this into addition is that now I just connect everything with an addition sign. I don't have to think about what sign I'm using. It's always going to be addition. So I've got y squared plus negative 2y plus negative 1y plus 2. Now, much like question 1, however, these two numbers here, these two terms, are like terms because they're both regular y terms. So we can actually combine those and make that into one thing, so I can write a fully simplified expression. Negative 2y and negative 1y combine with addition to make negative 3y's. So I'm actually going to combine those to write negative 3y. So I'm going to write y squared plus negative 3y plus 2. So 1 plus negative y being multiplied by 2 plus negative y yields y squared plus negative 3y plus 2. If you're wondering why I wrote the y squared first, even though it's in the last box, remember, as we've talked about many times in this polynomial chapter and section, the book really likes standard form. It doesn't say anywhere you have to use standard form, but it is something they really like. Remember, standard form simply means you write the biggest exponent thing first and the smallest or no exponent thing at the end, and they drop down in order. Well, that's exactly what I've done. I've got the exponent of 2 first, then the exponent of 1, and then the no exponent. However, it is not required. You can write them directly in the order they appear in the boxes, and you'll have no problem. All right, so let's go ahead and take a look at number 3. 2x plus 1 being multiplied by 2x plus 4. So I'm prepared to do another table here. And what's nice about this one is this one's already all additions, so I don't really have to spend any time thinking about changes here. I can just go ahead and dump this into the table and multiply. So I've got 2x plus 1 across the top and 2x plus 4 down the side. All right, so let's go ahead and simplify what we got here. So I got 2x above this box and 2x to the left of that box. So I need to combine those. Well, the 2 and the 2, as you know, is going to combine to make 4 with multiplication. And the x is going to combine to make x squared. Again, the product of powers rule says when we're multiplying things together with the same base, that's the big number, we add their exponents. Yes, I understand I said multiplication, and I understand I said add the exponents, and no, I did not misspeak. That is what the rule says, the same rule you were taught earlier this year. So x times x makes x squared. All right, the next box down features 2x above it and 4 to the left of it. 2x times 4 is going to go together to make 8x. 2 times 4 is 8, append the x. This upper right box has 1 above it and 2x to the left of it. Well, of course, multiplying by 1 doesn't change anything, so it's still 2x. This bottom box here has 1 above it and 4 to the left of it. 1 times 4 is 4. So we're going to go ahead and combine these, but once again, as you can see on this one diagonal here, we have a set of like terms. So we're going to combine those to write a fully simplified answer. Again, everything is going to be connected with additions. So 2x and 8x is going to go together to make 10x's. So I've got 4x squared plus 10x plus 4. All right, let's go ahead and take a look at question number 4. The last one I'm going to help you with on the top, then I'm going to scroll down to the bottom here. In number 4, we've got w plus 1 being multiplied by w minus 3. All right, so as you can see, we do have a subtraction here. And again, one of the benefits here of using the table method is we don't have to think about signs. But we can only do that if we fix the signs originally. So getting rid of the w minus 3 part is essential because I have to change that into adding the opposite to solve here. So I'm going to go ahead and fix that and rewrite this as w plus 1 being multiplied by w plus negative 3. Alright, so this is now set up correctly for the table method. So let's go ahead and use that table method here. I'm going to list w plus 1 across the top. Again, I don't really need to write the plus sign because we know we've made that fix. And w plus negative 3 down the side. Again, each box is the product of what's above it and what's to the left of it. So this box here has w above it and w to the left of it. W times w is w squared. Again, as you've heard me say in the last few problems here, product of powers rule, when we're multiplying together powers with the same base, we add the exponents. Yes, again, I understand it's a multiplication problem, but we're adding the exponents by rule. All right, the next box down has w above it and negative 3 to the left of it. So that's going to give me negative 3w. This box here has 1 above it and w to the left of it. 1 times w is 1w. And this box here has 1 above it and negative 3 to the left of it. 1 times negative 3 is negative 3. So we'll now combine all these parts with addition signs. But once again, like the last two problems on this diagonal here, we have two with that are like terms. They have the same variables to the same power. So we can combine those. I have 1w and negative 3w's going together to make negative 2w's. So final answer here is w squared plus negative 2w plus negative 3.